more about the production of hydrochloric acid in the stomach. And as you can see, or if you look back at your notes, this takes place in the parietal cell. And here's how it happens. So let's draw the parietal cell. There's the parietal cell. On this side we have the stomach, or the inside of the stomach. This is in the wall. The parietal cell is in the wall of the stomach. And over here, we're going to put the bloodstream. So this is blood. That's blood. So you are out running around, you're moving, and with cellular respiration, you start breaking down your glucose through cellular respiration, and you produce CO2. So you're going to have CO2 in your blood. And what the parietal cell does is it brings in the CO2 from your bloodstream into the parietal cell. So now you have CO2. And inside your parietal cell, you also have water. And if we combine CO2 and water together with the presence of an enzyme called carbonic anhydrase. In the presence of carbonic anhydrase, CO2 and water come together to make carbonic acid, H2CO3. And this is the same as acid rain. So if you take a glass of water and you take a straw and you start blowing your breath into that glass of water, you will make carbonic acid. Same stuff. H2CO3, carbonic acid. Now, you have to think back to your chemistry days. So Peyton, you'll get to this eventually, Peyton Walters, eventually you'll get to this in chemistry, but everybody else has had chemistry. In chemistry, when we're dealing with acids and bases, there's something called dissociate. So when you have an acid and H2CO3 is an acid, when you put it into water, it does something called dissociate. And what that means is it simply breaks apart. And we're going to break this into H plus and HCO3 negative. And HCO3 negative is called bicarbonate. And by definition, let me scoot this over a little bit. By definition, bicarbonate is a base. And why is it a base? Well, if you'll remember back to chemistry, any ion that will accept or take a proton, and you know that H plus is a proton. My video quit here. Hold on a second. Okay. You know that H plus is a proton. And since this HCO3 is negative, it will take that proton, therefore it is a base. So our HCO3 is a base, and we have H plus. So right here, back up into the cell, this breaks apart into H plus and to HCO3 negative. This H plus is put into the lumen of the stomach. It's put into your stomach. Where does the chlorine come from? Well, the chlorine also comes from your bloodstream. I didn't draw my cell big enough, but you have chlorine in your stomach or in your bloodstream. And you eat sodium chloride, right? So when you eat salt, NaCl, it breaks apart in the bloodstream into Na plus and to Cl negative. And that's where the Cl negative comes from. So the parietal cell pumps the HCO3 into the bloodstream in exchange for the chlorine. And the chlorine will eventually come over here, and it is also put into the stomach. And in the stomach, that is where the H and the Cl combine to make HCl. And there's your stomach acid. So in review, you have CO2 in your bloodstream. And the reason you have CO2 in your bloodstream is because of cellular respiration. So we have CO2 and it gets put into the parietal cell from the bloodstream. It combines with water in the presence of carbonic anhydrase. It produces H2CO3, carbonic acid. The carbonic acid immediately dissociates into H plus and to HCO3 negative, which is called bicarbonate. The H plus gets pumped into the stomach. The chlorine is exchanged for the HCO3 negative, the bicarbonate. It's exchanged, and the Cl negative is put into the stomach. And at that point, the hydrogen and the chlorine are put together to make hydrochloric acid.